Alright, so a little more information for you. The commuter lot I'm in is right next to an American furniture warehouse. And a Wendy's, and a Del Taco, and a Popeyes, and a 7-Eleven Shell, and a Carl's Jr. There's a lot of fast food right here. I am resisting the urge. And a Burger King, and a Pizza Hut, and a Mumtaz Europlace, and a Home Depot. Do you know where I am? Oh, I see a Starbucks also, and I see a Good Times, and I think that's everything. But wow, I could eat for days and days and days. Let's talk about this problem, though. So, this problem. This is getting at what we were just talking about. If the point -1,4 is on the graph of a function f of x, what other point must be on the graph of f of x, given that f of x is an even function? Well, remember what it means for a function to be even. It means f of -x will be the same as f of x. What that means is we have like x squared, we have symmetry across the y-axis. So if we have -1,4, we must have the point +1,4. Change the x value, maintain the y value. Alright, well, what about the next one? What if f of x is an odd function? Well, remember that definition. That says if we take f of negative x, we will get negative f of x. And again, what does that mean in more easily understandable terms? It means if you flip the x value, you must also flip the y value. So, change both. If we have -1, +4, we must also have +1 and -4. Symmetrically speaking, this is like a cubic graph like that, with that key middle thingy right smack dab on the origin. If I have one, let's do this. If, maybe it looks more like that. If I have 1, -4 right there, I have to have -1, +4 right there. Flip it across the x-axis and flip it across the y-axis. You got to do both. That makes it an odd function. And then finally, if we have the point -1,4 on the graph of f of x, what point has to be on the inverse of f of x? Well, what is an inverse? Think about how you solve for an inverse. If you have, say, some function y equals 3x plus 7, what do you do to find the inverse? Well, you switch x and y. X equals 3y plus 7, and then you solve for y. So x minus 7 over 3, like that, has to equal y, would be the inverse function of that example problem. But think about the key thing we just did. We switched x and y. So if -1,4 is on there, then on the inverse we must have 4, -1. You literally are just switching them, and that's it. Think about x squared versus the square root of x. Think about x cubed versus the cube root of x. Every single point on both graphs is on the other graph, but flipped x and y. Boom. Alright, and now I can see the people I'm meeting are at the stoplight pulling up, so it's time for me to stop making videos, and now I'll just tell you, waiting to meet up with some friends to go ride trials in Wyoming. Look up observed trials, or motorcycle trials if you don't know what it is. That's what I'm going to do, so I will see you later, and we will talk about this problem. What's up, everybody? No idea where I left this video off, because I started it on Saturday. Alright, and now I don't know where I just left that thought off, because Lair just walked in and we talked about physical therapy on ankles. So, it's Monday morning. I'm eating a muffin at my desk. Students are about to walk in, probably will walk in while I'm talking, but let's go ahead and get started. We're going to use this graph to evaluate the composition of functions. So the key is look on the inside first. So if we're doing A, first thing we need to do is evaluate g of -2. So all that means is go to the x value of -2, which is right there, and then go to wherever the graph is, which is right there. That value is 2. So g of -2 is 2. So now this question becomes, what is f? of 2. And that means the same thing. It means go to the graph of f, go to the x value of 2. Where's your graph? What's the y value? Well, there the y value is negative 2. So f of g of negative 2 is negative 2. Boop, 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 boom. Okay, next one, we are multiplying here. So let's figure out what f of negative 1 is. So we go to our graph. Negative 1 is right there. The y value is 2 right there. So we know f of negative 1 is 2. That looks like a z. 2 times g inverse of 3. Now the inverse is slightly confusing. G inverse of 3 is saying go to your graph of g. Where is the y value 3? The y value is 3 right there. What's the corresponding x value? I lied. That's negative 3. Where is the y value 3? Y value 3 is right there. And then the corresponding, oh my gosh, what am I doing? I'm making you confused. Let's start this from the beginning. I clearly need to start drinking my coffee because I'm talking gibberish. G inverse of 3. That is saying, go to the graph of g, find the y value of 3. Y value of 3 is right there. What's the corresponding x value? Well, there is the corresponding x value, which is negative 3. Sorry about that. That was a little gibberish right there. So 2 times negative 3 is negative 6, just like that. Inverses just work the opposite. Instead of going to the x value, go to the y value and get the x value. So g inverse of f of 0. Find f of 0 first. It is not that point right there. Now that open circle right there means that our function does not take on that value. You need to find the corresponding spot with the closed circle right there. So f of 0 is 3. So now we're asking ourselves the question, g inverse of 3, which if you look at the last problem, we already know what that is. That is negative 3. So our answer is just negative 3. And now let's do the last one. It is gross and obnoxious and long, but we can do it. Go to the uber inside first, g of 2. So go to the graph of g, find the x value of 2, take the corresponding y value, which is negative 1. So this becomes f of f inverse of negative 1. Go to the inside again. What is f inverse of negative 1? Well, that means go to the graph of f, find the y value of negative 1, use the corresponding x value, which is 1. So this becomes f of 1, which says go to the graph of f, find the x value of 1, use the corresponding y value, which we already know is negative 1 because we just used it. So f of 1 right there is negative 1. And that's kind of interesting. F of f inverse of negative 1 is just negative 1. I wonder if there's some deeper implications there. And finally, let's talk about e. So now we're defining a new function, h of x, which is just going to be our function f divided by our function g. And we are tasked with explaining why x equals 3 is not included in the domain. Well, it's fairly simple. G of 3 equals 0, and g of x is the denominator of our function h of x, and you cannot have a 0 in the denominator. It will create a vertical asymptote, so 3 cannot be included in that domain. And then the next part of that question is, how come the y values will go from 0 up to infinity? Well, the key thing to recognize here is that from negative 3 to 0 on both graphs, our y values are positive. So that fraction, h of x, is going to be positive. From 0 up to positive 3, the y values are all negative. So again, that fraction is going to be positive. A negative over a negative is giving us a positive. So that bit right there tells us that all these numbers are going to be positive, at least. But then we look over here at this point right there on f, where f of x, f of negative 3, equals 0. And since f is the numerator, that tells me h of negative 3 also equals 0. So now we know it can be 0 as well. And we already said we have an asymptote at 3, and it's positive, which means our graph must shoot off to infinity. and thus the range must be y values greater than or equal to 0.